Today we're going to solve quadratics by using the quadratic formula. So the first question is, what is the quadratic formula? The quadratic formula is x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. So you need to start memorizing this formula. Tomorrow I will teach you a song to help you remember it, and I will also show you where this quadratic formula derives from, meaning where did we come up with it from. The next important part to know is the discriminant. So the discriminant is b squared minus 4ac. And notice that this is the expression that is underneath the radical. And this is a very important part of the formula because this is the part that tells us how many solutions we're going to have. So if our discriminant is a positive number, meaning that b squared minus 4ac is greater than 0, we are going to have two solutions. And notice when we look at a graph, no matter whether it opens up or down, these two graphs both have two x-intercepts, which is why there are two solutions. If the discriminant equals 0, then there's going to be only one solution, and that solution is going to occur at the vertex. So notice both of these graphs have only one point touching the x-axis, and it's on the vertex, which means there's only one x-intercept. And if the discriminant is less than 0, meaning it's negative, there will be no solutions. And if you look at these graphs here, no matter where I look, this graph will never touch the x-axis, either one of them, whether it opens up or down. So this tells me that there are 0 x-intercepts, which means there are no solutions. So down here, we're going to actually look at finding the discriminant and determining the number of solutions based on that discriminant. So the first thing we have to know is that you have to make sure that it is in standard form, meaning it's ax squared plus bx plus c, and it has to equal 0. So all three of these equations in this box fit that criteria. The next thing is you need to identify your a, your b, and your c. So a is always in front of x squared, b is in front of x, and c is going to be the constant. So our a for this first problem is going to be an understood 1. Our b is a negative 3. Remember, you keep the sign with it. And our c is a positive 7. So if I was to ask you to find the discriminant, you would simply plug in these values into b squared minus 4ac, meaning we would have to put negative 3 in parentheses minus 4 times a, which is 1, times 7. Now it's very important that you put the negative 3 in parentheses, otherwise you will get the wrong answer, because negative 3 squared without the parentheses is a negative. However, negative 3 in parentheses squared is a positive 9. And then we have negative 4 times 1 times 7. Since there's only one negative here, this product is going to be negative, and 4 times 1 times 7 is 28. So 9 minus 28 is negative 19, and because this is a negative value, there will be no real solutions, which means there will be no x-intercepts. So the second one, our a is an understood 1 again because the x squared has an understood 1 in front of it. Now notice we don't have a bx term, which means our b is going to be 0, and our c is going to be negative 3. So again, we're going to use our b squared minus 4ac. So b is going to be 0 squared minus 4 times 1 times c, which is negative 3. So 0 squared is simply 0. Because there are 2 negatives, this product is going to be positive, and 4 times 1 times 3 is 12. And 0 plus 12 is 12. So since this number is a positive number, there are going to be 2 real solutions, and there are going to be 2 x-intercepts. All right, last one. A is going to be 4, B is -12, and C is 9. So go ahead and pause the video, figure out the discriminant, and then tell me the number of solutions and the number of x-intercepts. When you're ready, turn the video back on. Right, when you multiplied out the discriminant and you simplified it down, you should have gotten 0 as your answer. And since the discriminant equals 0, this means there is going to be 1 real solution, which means there's going to be 1 x-intercept. And this x-intercept is going to occur at the vertex. Okay, so these are the 3 possible solutions we could have: none, 2, or 1. And notice either a negative, a positive, or a 0 discriminant. Now I'll tell you another secret about the discriminant. If the discriminant is a positive number that is a perfect square, meaning if the discriminant had equaled 49 or 25, then that would have given us a clue that the problem would have factored. So like here, where the middle problem where the discriminant is 12, this is not a perfect square. So this problem, x squared minus 3, is not a factorable expression, which we can tell because the numbers are small. But if numbers are rather large and you're wanting to know if something factors quickly, you can just use the discriminant and see. If it factors, you can factor it. If not, you could use the quadratic formula. So now we're going to actually get into using the quadratic formula. So we're going to start with a somewhat small problem. So number 1 is going to be x squared plus x minus 6 equals 0. So remember, to use the quadratic formula, it has to be in standard form equal to 0. And this is in standard form, and it does equal 0. So we're going to identify our A, our B, and our C. So in this problem, our A is 1, our B is 1, and our C is -6. And then we're going to use our quadratic formula. So our quadratic formula is x equals -b plus or minus the square root of b squared minus 4ac all over 2a. And we're going to take our values and we're going to plug them into our formula. So x equals, we have negative, and then our b is going to be 1 plus or minus the square root. B again is 1, and if it's a positive number, you don't have to put it in parentheses, but if it's a negative, you do. So it's a good habit to go ahead and put that number in parentheses, and then you never have to worry about, well, do I need them or not? Minus 4 times 1 times -6 all over 2 times 1. So now the next step is to start cleaning things up. So I always start with the discriminant. Now it is possible to type this entire expression into your calculator. However, if you do not have a good calculator, you're going to have to do it by hand. And it's really a good idea to go ahead and get the discriminant simplified down, because if the answer is not exact, you would not know that unless you're doing this by hand. So -1 plus or minus, underneath my radical, I'm going to have 1 squared, which is 1. So I have a negative and a negative here. So there's 2 negatives, a -4 and a -6, which tells me that this is going to be plus, and then 4 times 1 times 6 is 24. And then on the bottom, we're going to do 2 times 1, which is just a 2. So we're going to continue cleaning this up. -1 plus or minus the square root. 1 plus 24 is 25. And this is all over 2. And this is nice because 25 is a perfect square. So this means that x equals -1 plus or minus the square root of 25 is 5 all over 2. So now we need to actually simplify this down. So this actually means -1 plus 5 over 2 and -1 minus 5 over 2. So -1 plus 5 is 4, and 4 divided by 2 is 2. So our first solution is 2. Negative 1 minus 5 is negative 6, divided by 2 is negative 3. So our solutions here are 2 and negative 3. And if you were to plug these answers in for x, you would get that this equals 0. So 2 squared is 4, plus 2 is 6. 6 minus 6 equals 0. Negative 3 squared is 9. 9 plus negative 3 plus negative 6 is 0. So you can check your solutions, especially when they're nice integer values. So let's try number 2. Number 2 is going to be 3x squared equals 4x. So the first thing we have to do is we have to get this into standard form. I know it's not because it doesn't equal 0. So to get it equal to standard form, I'm going to have to subtract the 4x to the other side. So that would give me 3x squared minus 4x equals 0. This is now in standard form. So now we need to identify our a, our b, and our c. So our a is going to be 3 because it's in front of the x squared term. Our b equals negative 4 because it's in front of the x term. And since we don't have a constant, that means our c value is going to be 0. So now we're going to write down our formula. X equals negative b plus or minus the square root of b squared minus 4ac all over 2a. And then we're going to plug in our values. So x equals negative 4. And notice how I'm writing these two negatives. A lot of times students will do this in their head and they'll forget to actually have a double negative, which makes it a positive. So be very careful that you're writing things very neatly and strategically. Now here we have to put negative 4 in parentheses when we square it. Minus 4 times 3 times 0 all over 2 times 3. So x equals, the opposite of negative 4 is positive 4, plus or minus, negative 4 squared is 16. Now, the very fact that I have a 0 right here means this whole product, this entire product, is going to have to equal 0. So 16 plus 0, which is just 16. So there's really no need to write the plus 0. And that's going to be all over 2 times 3, which is 6. So 4 plus or minus, the square root of 16 is 4, and then divided by 6. So again, remember, this really means 4 plus 4 over 6 and 4 minus 4 over 6. So this is two separate equations. So we end up with 8 over 6 and 0 over 6. So now we just have to simplify. So x equals 4/3 is our first fraction, or 1 1/3. And then 0 divided by 6 is 0. Right? Now, if you would have noticed, this problem would have been much quicker to do by factoring, because you could have factored out a GCF. But the quadratic formula does work for every single problem we've done, and so that makes it a good option when nothing else is working. So the last one I'm going to have you try on your own. So number 3 is going to be 5x squared plus 2 equals 0. So try this one on your own. When you're ready, turn the video back on. Alright, hopefully you were able to get the formula written down and plugged in. So you would have noticed that you end up with a negative 40 under the radical. Since the discriminant is negative, this would tell you that there are no real solutions. So there's no reason to continue doing this problem, because this right here cannot be negative. This can't be negative. If it is, then there's no real solutions. So that's what we're going to put down as our solution. No real solutions. So remember, there is a solution, it's just not a real number. It would be a complex number. So that's why we have to write no real solutions.